So today we are going to see about these alcohols, phenols, and ethers. You are familiar with alcohols, isn't it? So what do you mean by alcohol? Alcohol means is nothing but replace H with OH in aliphatic hydrocarbon. Okay, so replace H with OH. Replace H with OH in the hydrocarbon, in aliphatic hydrocarbon. So I hope that you know the difference between aliphatic and aromatic. So aromatic means it's a ring structure. There is, for example, if a phenol, benzene, naphthalene, இதெல்லாம் வந்து aromatic smell. Aliphatic is it's a open chain compound. Okay, it's in aliphatic hydrocarbon. So if you are replacing hydrogen with OH, you know that the formula for aliphatic hydrocarbon, general formula CnH2n plus 2, isn't it? So here, if it is an alcohol means it will be like this CnH2n plus 1 OH. Okay, so instead of one H, OH will be replaced. Okay, that is aliphatic alcohols. That is alcohol. For example, so alcohol is one family. Like alkane family means alcohol ஒரு family தான். So இப்போ alcohol family நிறைய members இருக்கு. So the first member always will have one carbon, no. So example is it's methanol and ethanol. It will be go like that. Okay, ethanol. Here the functional group is its OH. Okay, functional group is OH. So functional group OH இருக்கிறதுனால almost properties of the members of the families also will be the same. Okay, this is aliphatic. This is alcohol. Okay, but what about the phenol? So phenol means it's an aromatic. Actually, it's an aromatic compound. So this is benzene. Benzene is an aromatic. Okay, benzene is an aromatic. So with OH means this is phenol. Okay, so this one it is phenol. Here the H is replaced by an alkoxy or a aryl oxy group. Okay, so this is phenol. Okay, then what about ether? Ether means uh, ethers. R O R dash. So this is the general form for ether. Okay. So இதுலயே வந்து alkyl group ethரும் இருக்கு, aryl group ethரும் இருக்கு. So for example, if you are taking like this CH3O C2H5, so this is ether, aliphatic. Okay. So aromatic means this by will be replaced by. Okay, just now I started Rayon that alcohol lesson. Okay, second lesson, which is alcohol, phenol, and ethers. What is alcohol? Alcohol means H is replaced with OH in aliphatic hydrocarbon. So it's like this. Okay, CH3OH, C2H5OH. So this is alcohol. And phenol is with aromatic hydrocarbon. One hydrogen is replaced by OH. That is phenol. And the ethers is CH3O C2H. This is the general form for ethers. Okay. So here the R, it may be an alkyl group or aryl group. It may be an alkyl or aryl. Okay, anything. So that is ether. Okay. So the ethers, it is a sweet smell. It has one smell. It is a sweet smell. Okay. So alcohol, phenol, ethers. But why do we need to learn? Okay. So that is the question. அது இருக்கட்டும். But why we want to learn this one? So why we need to because of its uses. Okay. So this one or these three are it's very good solvent for many chemical substances. For example, okay, wood polish. Okay, so this is a it comes under this variety. and it is also used. It is also used in cotton, beverage, drink, papers, cosmetics, and in preservatives. Okay, used to make bombs and explosives. Apart from that, it is used for making bombs and explosives. Explosive. It is also used as an anti-freezing liquid. Anti-freezing. Okay. Um, Anti-freezing. So, as it has many uses, we need to learn this compounds in detail. Okay. So we'll see one by one. First, you are going to see about alcohols. Alcohols. Okay, one or more OH group directly attached to carbon of an aliphatic system, which is called alcohols. Already we have seen, no, one or more OH group. It's directly attached to an aliphatic system. So here the OH, if you take in the alcohol means it's OH. Okay, so how we are identifying the compound with their molecular structure means is OH group with the functional group OH. Okay, so OH bond is actually it is a polar in nature. Okay, it is a polar in nature. OH is polar in nature. Why it is a polar? Why it is a polar? What do you mean by polar? Polar means it's like poles. Two poles are there, no? So on the earth, one north and south pole. The reason is north and south completely different. Okay, here also, why it is a polar means so because of oxygen, no? So oxygen is more electronegative. Okay, it's because of the electronegativity difference between oxygen and the hydrogen. It is polar in nature. Okay, so it is slightly OH is more electronegative. Okay, so because of that, so there will be a polarity in nature. So polarity in nature means so how it will be like this, no? So as this is a uh, high electronegativity, it pulls the electron towards itself. So hydrogen, no, which attain a partially positive charge. If hydrogen is a positive, means definitely it has an acidic character. Okay, so it is slightly acidic. Okay, slightly alcohol is very slight. Okay, so it is slightly acidic. Don't think that because of this OH group it is a basic. Okay, because in the inorganic chemistry, so you are learning that NaOH and KOH. So all these are all possesses OH. Because of that, it is a basic group. But here it is completely different. OH alcohols, because of the presence of OH, it is a polar in nature, so it is slightly acidic. So acidic then water. Okay, slightly acidic means water. Acidic then water. Okay, acidic then so water. Okay, so this one is a classified. So if you are taking classification, classified as mono, di, tri, or polyhydric alcohols. Okay, classified as mono, di, tri, and polyhydric alcohols. So if you are taking notes, no, so it will be very good. So please try to take a notes. I will send these notes through WhatsApp. But still, if you are taking notes with your own handwriting, so it will be very good. Okay. So polyhydric alcohol. For example, mono means it's a one OH group is there. C2H5OH. So this is mono. Okay, this is mono. Di means it's a two OH group. Two OH group. Okay, so this is di. Name of this compound is a glycol. Okay, common name, familiar name, it's a glycol. Then tri means it's a CH2OH, CHOH, three alcoholic group. It's a tri glycerol. Okay, so glycerol. So these are the classification of alcohols, monodi and tripolyhydric uh, compounds. Okay. So if you take monohydric alcohol, this one, if you take a phenol, okay, uh, in phenol, this is all about it's an alcohol. This is on about alcohol. Okay. So if you take a phenol, so we need to learn about the phenol also, no? So phenol, so it is a solid compounds. Okay, so they are solids. Here OH is attached to aromatic system. OH is attached to aromatic system. Okay, so that means OH is attached with the benzene ring. Okay, so this is phenol. Okay, this one is a phenol, but if you are taking you in the last lesson, so we learned about its benzyl. Okay, so what is benzyl? Benzyl also which are having it's a um, this aromatic ring, but CH2OH. So this is phenol. Okay, this is phenol. This is benzyl alcohol. This is benzyl alcohol. So actually this carbon is not, actually this will not come under uh, this aromatic system. Okay, and the reason is, okay, so this is the one, OH is attached with the aromatic system, but here the OH is not attached with the aromatic system. Okay, here the OH is this carbon, that means this is a star carbon. Okay, so this star carbon is not a part of aromatic system, so it is not a phenol. So it is not a phenol, so don't get confused. Now you have to know the difference between benzyl alcohol and phenol. Okay, so it is not a phenol, it is a type of alcohol. Actually it is a type of alcohol, but aromatic alcohol. Okay, it's a type of alcohol, but still it is aromatic. Okay, this phenol, no, so this phenol which is more acidic than alcohol, more acidic than alcohol. So actually how it will means it's a phenol which is more acidic. Okay, so phenol is more acidic than um, alcohol. Okay, so this is about phenol. So again, so there is a classification is there for this phenol also, mono, di, and tri. So if you are putting this one, so this is one alcohol, this is mono alcohol, this is mono. Okay, so it's a di means we know that in the di-alcohol, in the two places, it may be an ortho, para, or meta. All the three are di-alcohols only. Okay, so this is ortho. 1, 2, 1, 6 ortho, 1, 3 meta, and 1, 4 it is a para position. So all the ortho, meta, and para position comes under the classification of di. Okay. Then if you are taking tri, try maybe it's like this, it's an OH, it's an ortho. Okay, and it may be an ortho para, or it may be an ortho and meta, anything. Okay, or it may be this side ortho and para. So this is a trihydric um, alcohols. Okay, okay, so the ethers, if you are taking ethers, Okay, so now we are going to see about ethers also. Okay, so just we are introducing this topic ethers. Now it's an ethers. So ETH is actually which is classified as simple or symmetrical. So ethers means I said no. So this is the structure R O R dash. So this R and R dash it may be um, alkyl or aryl. Okay, so alkyl or aryl. So that is R O. So this this may be an alkyl or aryl. So this is also an alkyl or aryl. So this is the structure of ethers. So if you take ethers, it may be a simple one or simple or symmetrical. Okay, simple or symmetrical or unsymmetrical. Okay, so simple or symmetrical means so both alkyl groups are same. If both alkyl groups are same, like this CH3 OCH3 or C6H5O C6H5. So both the groups, both the whether it is an alkyl group or aryl group are same. So this is simple, okay, or symmetrical. If it is a mixed or unsymmetrical means mixed or unsymmetrical. So the both groups are different. Okay, so both the groups are different. For example, it may be CH3O C2H5. This is a mixed one or unsymmetrical, or C6H5O CH3, anything. Okay, so it may be mixed with two different alkyl groups, or it may be mixed with alkyl and aryl group, anything. So if it is like that, so this is unsymmetrical ethers. Okay, so this is all about ethers. Okay, so we'll see one by one. The first one it is alcohol. Up to this, any doubt for anyone? Okay. So we'll see about it. It's an alcohol. Okay. So actually, alcohol. First, we have seen alcohol as it's classified as a mono, di, tri, and polyhydric alcohol, which is based on 1, 2, 3 OH group, isn't it? So this alcohol, no. So it may be further classified according to hybridization. Okay, classification based on hybridization. Classification which is based on hybridization. So hybridization means it may be an sp3. Okay, the first one compounds, first classification, compounds containing sp3 uh, carbon OH. Okay, it may be classified as sp3 sp3 carbon with OH. So that means that the star carbon, so it is an sp3 carbon. Okay, so under this there is some classification is also this. So it may be a primary or secondary or tertiary. Okay, then it's an allelic. So you are familiar with allelic and benzylic, no? So in the first lesson itself we learned. So this is allelic and benzylic. So this is first classification. In the second classification, which is based on sp2 carbon OH. So that means this star carbon is an sp2. Okay. Here we are going to learn about vinylic and phenol. Okay. Okay. So we'll see one by one. First, we will see sp3 carbon OH. That means OH functional group is attaches with sp3 carbon. Okay. So they are generally liquid. Where generally it's a liquid. So it may be like this. Okay, CH2OH, the first classification, it's a primary, secondary or tertiary. That OH group, functional group. Okay, so which is attaches with one carbon or zero carbon, it is a primary, isn't it? So this one it's a primary because this OH functional group which is attaches with the one carbon. So it may be connect or combined with one carbon or zero carbon. It is a primary. Okay, then if you are seeing that the secondary CHOH, this is secondary, and the tertiary means so three this carbon, that is the star carbon, which is attaches with the three other carbons. Okay, so this is primary, secondary, and tertiary classification. This is the first classification. Second, second classification, it is allelic. Okay, this is allelic. What do you mean by allelic? Star carbon, this is a star carbon. That means the star carbon is nothing but the carbon in which functional group is attached. Okay, so the star carbon attached to carbon which has a double bond. Star carbon which is attached to to carbon which has double bond. Which has double bond. So that is allelic. Okay. So this is also liquids. Okay. Yeah. For example, if you take this one CH2 double bond CH2OH. Okay. So here the star carbon is attaches with the carbon which has a double bond. Okay. So this is a star carbon. This is an allelic. This is also an allelic. CH2, CH, CH, CH actually. So here OH, so that means this is a star carbon. So this is a star carbon. Here the star carbon is primary. It may be a secondary or tertiary. So if it is like this is a tertiary actually. This is a tertiary. This is also allelic. This is the primary. This is also allelic. Because what we have to say means the star carbon which is attaches to a carbon which has a double bond. Actually here it's a double bond. Okay. This one is a secondary. Okay. So this is allelic. It may be a secondary also. Okay. So like this CH2 double bond CH C. Um, okay. So if it is like this, so this is a star carbon, which is attaches with the two other carbons. So this is a secondary. Okay. So this is all about allelic. Then benzylic. This is benzylic. Okay, benzylic, if you are seeing that benzylic CH2OH, CH2OH, but this star carbon is not part of the aromatic system. Okay, this is not part of the benzene ring. Okay, so this is primary. Okay, what about secondary? This is secondary. So if it is attaches with the two carbon, so this is secondary benzylic, and tertiary means this carbon which is attaches with the three other carbons. Okay, so this is a star carbon. This is a star carbon. So this is tertiary. Okay, so this is tertiary. This is all comes under sp3 carbon OH. OH is attaches with the sp3 carbon. Understood? Understood. Any doubt? Okay. So for next one, sp2 carbon. Okay, sp2 OH is attaches with the sp2 carbon. So here there are two. I think we have seen. One is vinylic and another one phenol. So this vinylic, we'll see that vinylic. CH2 for here the star carbon is attached to the star carbon itself is attached to double bond. Itself is attached to double bond. So the same thing we learnt in haloalkane also. Okay, so that means CH2 double bond CH OH. So here the star carbon which is attaches with the carbon carbon double bond. So if it is like that, so that is vinylic. Okay, vinylic. And then the second classification under this one, it's a phenol. We know about if it's a phenol, no? So sp2 carbon with OH. That means here also the star carbon itself is attaches with the. This is a star. Everything, all the six carbon are sp2. Okay, so that means here the star carbon itself which has a double bond. This is phenol. Okay, this is phenol. And even in this Malic alcohol, phenol, it may be like this also. It's an OH and CH3. Okay. So this is an example for phenol. Okay. So this is the classification of alcohol. Alcohol and phenol we have seen. We'll see next. So classification is over. So next one, it's an IUPAC. Again, I'm saying that IUPAC. If you are knowing the rules only, we can go through that. Okay. So IUPAC, if you take IUPAC, no, so many rules are there. So you may have a doubt why we need to give name like that. So if you are go through that means it will be easy. But still, I have given one or two. We will discuss one or two namings of IUPAC. Okay. Different nomenclature. Uh, for example, okay, only one alcohol group is there. So in the common name, methyl group. This is alcohol group. So common name is this is methyl alcohol. Okay, so this is a common name. But in IUPAC name, alcohol for alcohol, the name should end with OL. Okay, OL. So here actually this one it is derived from methane, isn't it? So this is derived from methane, and this is from alcohol. This is from alcohol. So what we are going to do by naming means instead of E, we are going to add OL. Okay, so that means um, methanol, methanol or OL. Okay, so OL is in and E out, methanol. Okay, the same way it's an ethanol, propanol, butanol. So these and all you know. Okay, so this is one example. The next one, if you take this one, CH3, CH2, CH2, CH2OH. Here the OH is attaches. Here while giving the name, it's very important. The functional group gets the lowest number. So 1, 2, 3 and 4. This OH is attaches with the first carbon. So totally it is 4 carbon is there. So the parent hydrocarbon is its butane. Okay, butane. Uh, this is an alcoholic group, so butanol. So it may be N-butanol or N-butan-1-ol or butanol. Anything is same, right? So then next one, if you take this is all it's a primary. So if you take a secondary, CH3, okay, CHOH, CH3. So this is isopropyl alcohol. Common name is an isopropyl alcohol. IUPAC it's propane. Okay, so it's a propane. In second carbon, OH is attaches, so propane to all. Okay, so propane to all. So in the same way, um, CH3, CHOH, CH2, CH3. So this is butane. Okay, so butane to sorry, butane to all. Okay, so in the same way, so many example they have given for alcohol. Uh, for cyclic alcohol, if you are seeing taking this is a cyclic hexane. Okay, so if OH is attaches with this, it's a cyclohexanol. It's a cyclohexanol. Okay, so if it is like this, cyclopentane, no? So this is cyclopentane. If, if the groups or substituents are attaches with this, here the functional group will get the lowest number. So it is 1 and this one it's a 2. So this is 2 methyl. Second position methyl group is attaches 2 methyl cyclopentanol. Pentan 1 ol or cyclopentanol, anything. Okay, this is all about IUP is the name of alcohol. If you take a phenol, no, so phenol, we know the position of ortho and para and meta, no. So this is phenol. One OH group is this, that is monohydric alcohol. Uh, so if you so this is also monohydrate. It's an OH, OH, CH3 or CH3, OH, anything same. So here, this is an ortho position. Okay, alcohol is, the OH group is in ortho position. So orthocresol. So this is common name actually, orthocresol. If you want to write an IUPAC, 2-methyl phenol. Okay, so this one, 2-methyl phenol. So this is 3-methyl phenol. Okay, so this one it's a 3-methyl phenol or metacresol for metacresol. And if you take this one, so this is 4-methyl phenol or paracresol. Okay, so it's a 4 paracresol or 4-methyl phenol. Okay, so then, if this is all monohydric alcohol. So if it is a dihydric alcohol, no, so 2 alcohol groups are there. 2 alcohol groups means it's benzene. This is benzene 1,2 diol. Benzene 1,2 diol. This is IUPAC. If it is like this in meta position, so this is ortho position. This one it's a meta position. This is benzene 1,3 diol and this one. If you take this, it's an OH and OH. So this is 1,4. Okay, benzene 1,4 diol. It's a common name is it's a catechol. This one catechol. This one risosinol and this one it's quinol. Okay, either it's a quinol or hydroquinol. Okay, so benzene 1,4 diol. This comes under dihydric alcohol. Okay, now that ethers, no, UPSC name for ethers is little bit different, so you may get easily confused. So please see that ethers, UPSC for ethers. Common names for ethers are actually it's we have to it gets the name from its alkyl and aryl groups actually. So while writing notes, so in the alphabetic order we have to write. For example, if you take this one, CH3O, CH2, CH2, CH3. So here propyl group is there. Here it's an methyl group is there. Okay. So how do you name this one? It's methyl propyl ether. This is a common name. Okay. This is a common name. But IUPAC name, how do you write? How will you write IUPAC name for this one? So you may meet this one actually IUPAC name. So we have to check which one has more number of carbon. So two alkyl groups are there now, which has more carbon. So this side, okay, this is propane. Okay, so the name should end with propane. But what propane? What propane? This is methyl group is attaches with this uh, oxygen. So this one, it's methoxypropane. Don't write that propoxymethane. Okay, so this is methoxypropane. So always the parent hydrocarbon should have or must have more carbon atom. Okay, so this is methoxypropane. So if you take this one, C6 H5 O CH2 CH3. Here, which one has more carbon? This one. So parent is this benzene. So it should end with benzene. What benzene? Ethoxybenzene. Okay, ethoxybenzene. The oxy means that is ether. Okay, ethoxybenzene, not phenoxyethane. Don't write like that. Okay, so students easily will get confused about this. Um, then, if you take this one, C6H5O, then it's a CH2 six times, then CH2, CH3. Here, if you are seeing this side more carbon, so that means a 7 carbon, so it should end with heptane. Okay, so what heptane? Here, this is phenyl group, so phenoxyheptane. Understood? Naming? Understood by any doubt? One more example, we'll see that C6H5O, CH2, CH2, CH, CH3, CH3. So which side more carbon? Again this side. So it should end with benzene. But what benzene? This you have to name now. Now you have to give name for this one. So here this is a branched compound. 1, 2, 3, 4 carbon. So in the second carbon, methyl group is attaches. Okay. Uh, no, wait, this side only. Okay. So because here it is attaches with this ether, no, it should get low number. So this is one, 2 and 3, this one it's a 4. So this is 3 methoxy, 3 not methoxy, 3 methyl group. So 3 methyl butoxy. Okay, 3 methyl butoxy benzene. So this is the way you have to give name. Okay, so every rules are there in the video. So again today I will share. Please go through. Okay, so this is all about IUP is the name for alcohol, phenol, and ethers. Any doubt up to this for anyone? No doubt, structures. Okay. Now we will see the structures for alcohol, phenol, and ethers. We will see that. The structure means the structure of how the functional group is attaches with that. Okay, alcohol, phenol, the structure. So first we will see about it's an alcohol. So if you take an alcohol, so here one simple alcohol I'm taking. It's H and OH. Okay, OH. So if you take this one, if you take this one, the structure, because of the here oxygen which has two lone pair of electrons, no, two lone pair of electrons. So it has two lone pairs of electrons because of the repulsion. Okay, so there will be a repulsion between these two electrons. Because of the repulsion of two lone pairs, angle is 109 degree. So the angle is, it is 108, sorry, 108.9 degree. Okay, yeah. So slightly lesser than tetrahedral. Okay, the why it is a slightly these and all, it's a reasonable question. Why it is not 109 means 109 for tetrahedral it is 109, right? So tetrahedral it is 109 degree, but here 109 degree is not there. The reason, what is the reason? Because of the repulsion, because of the repulsion between two lone pair of electrons. Okay, repulsion between two lone pairs of electrons. Electrons of oxygen. That is the reason. Okay. So this is for alcohol. This is for alcohol. So if you take a phenol, take phenol. If you take a phenol, uh, this is O and H. Okay, again the two lone pairs are there. Here no, so this one it's exactly it's 109 degree. The reason is CO bond is here the carbon. So this carbon no, so this is sp2. So this carbon is sp2. So sp2 means more s, more s character. Okay, that means it is a try to attract uh, oxygen towards itself. So the bond length no, so the bond length is, it's a little bit shorter than this bond length actually. So you no need to buy got this bond length and all. Okay, so this is I think it's a 442 picometer. Here this bond length, this bond length is, it's 136 picometer. The reason is in the sp2 carbon. Okay, so this is an sp2 carbon. So it tried more, that means it's more s character, more electronegative, try to attract oxygen towards itself. So the bond is slightly lesser than the alcohol. Alcohol, the phenol, it has a slightly shorter length. So, okay, so that means it has partial double bond. Yes, because of the sp2 carbon. So the length is shorter. It's a partial double bond. This is for, it's a phenol. Okay. Now, if you are taking the structure for ether, here the carbon. So here the three CH3. Here also one carbon. It's a CH. Okay. Here the bond length is, it's 111 point. It's a 7 degree, and a bond length it is 141. Okay, so this is actually, it's a methoxymethane. So because of the bulky groups, okay, so because of the bulky groups means these groups on the both the sides, no. So because of the bulky groups, angle is more. Okay, angle is, it's a more. angle is its more. The bond length is almost the same. And the reason is because of bulky group which are repel each other. Okay, repel each other, the angle is increasing. So these two bulky groups repel each other, the angle is more. So that is 111.7 degree. The reason is bulky groups which are repel each other. Understood. So this is the structure of ethers. Okay, so the electron pairs. Now in ethers, two electron pairs, no, the two lone pairs, and two bond pair. So it has four electron pairs on oxygen. So tetrahedral arrangement, in a tetrahedral arrangement, but the bond angle is slightly higher than the tetrahedral. So due to the repulsion between the two bulky groups. Okay, so that is the reason here the bond length is almost same. Okay, understood. So this is the structure of um, functional groups in alcohols, phenols, and ethers. Understood? Any doubt? No, up to this, any doubt? Yeah, because now you are going to see about its preparation, physical properties, and the chemical properties. You should know the structure, IPs, and classification, all thorough. No? Any doubt? No? Please answer. I hope all are there. Are you there now? I don't know whether you are there or not because I'm always all are there now. Okay, any doubt? Okay. Arvind, any doubt for you? Okay. Okay. So we'll now we'll see about okay. So preparation and preparation of first one by one we have to see. First we are going to see about the preparation of alcohols. Preparation of alcohols. So if you are taking the preparation from alcohols, so there are three methods are there. Okay, so three methods are there. First one from alkene. From alkene. Okay, um, from alkene again under the heading of alkane, subheadings are there. Um, by acid catalyzed hydration. By acid catalyzed hydration, which is the one method. Hydroboration oxidation, another method. So all these methods which are comes under um, um, from alkene. Okay. Uh, okay, we'll see. First one from alkene. There is a mechanism is there for this method. Okay, so only I think your book mechanism is very important. Seven or eight mechanisms are there in your book, I think. Okay, so all the mechanisms you have to write and practice. Okay, so this is the first mechanism you are going to see. So I will teach how you have to write and how you have to put the arrow mark, everything I will teach. So based on that, so you need a practice to thorough with the mechanism. Okay, so okay, from alkene by acid catalyzed hydration. So by alkenes, no, so react with water in the presence of acid as a catalyst to form alcohols. Okay, so if it is a symmetrical alkene, so there will be no problem again. So this is a symmetrical alkene. Okay, this is symmetrical alkene. No? So water when it is treated with symmetrical alkene in the presence of acid, in the presence of acid, so we will get an alcohol. So H is attaches with one carbon and OH is attaches with the other carbon, will not get any problem. So this reaction is a reversible one. Okay, but if you take unsymmetrical, okay, unsymmetrical, so this unsymmetrical alkene, so it go with the reaction, addition reaction which it takes with Markovnikov's, according to Markovnikov's rule. Okay, what this Markovnikov's rule says, the negative part adds to the less hydrogenated carbon atom, so that is Markovnikov's rule. Okay, CH3 CH double bond CH2, so this is unsymmetrical. So when a water, which is water means it's a H plus and OH minus, the reaction is taking place in the presence of acid. So the reaction go with according to Markovnikov's. Markovnikov's means this negative part which is adds to the less hydrogenated carbon. When you are comparing these two carbon, that means the carbon between the double bond, whichever has less hydrogen, okay, in that carbon only this negative part will attaches. That is the Markovnikov's rule. The negative part will attaches with the less hydrogenated carbon. Okay, so in that case you will get CH3. That means the secondary product will be a major product, while the addition reaction go with Markovnikov's rule. Okay, CH3, CHOH, CHOH, and then it's a CH3. So this is a secondary alcohol. This is a secondary product. Actually, this is symmetrical means no problem. Unsymmetrical means it's go with Markovnikov's rule. Okay, go with its Markovnikov's rule. Okay, so this is the reaction actually. So now we are going to see the mechanism for this reaction. We will see that. Okay. If you are seeing the mechanism of the reaction, so the mechanism of the reaction which involves three steps, okay, which involves three steps. The first step, it's always be the protonation. Okay, so protonation of alkene to form carbocation. Okay, so the first step, it is protonation. That means the formation of carbocation is taking place by electrophilic attack of water. So first, before it attacks, so water, how it changes, why we are using this acid, we will see that. Hydrogen, it's a water with react with, it mixes with H plus, that means H plus present in acid, and it becomes H3O plus. Okay, and it becomes H3O plus. So what will happen now? So the H3O plus will attack alkene. Okay, if you take alkene, so this is alkene and H3O plus hydrogen. This is H3O plus. No, we know that oxygen which has why we are putting plus here means it has a two lone pair electrons. So it will give this two lone pair of electrons. No, it passes its electron to this hydrogen and you will get here. As this oxygen is giving electron, it is a deficient of electron. Okay, so that is what we put plus to oxygen. The same thing here we are doing. Okay, so this is H3O plus. Now what will happen? So due to this electronegativity, same almost carbon, both are having same electronegative, but any one carbon will attain positive because of the polarity. Any one it is a plus. Okay. So now what will happen now? So or it may be like that, this also. If you take this one, so don't think that, so anything one, anyone is positive or anyone is, it's a negative. So if you are seeing that, okay, it may be a negative or it may be a positive, anything. So now what will happen? So it will give the two electrons to this. It's a negative, no? So this negative. So you have to do the arrow mark. So here the carbon, which is more negative, so it wants to give its electron to this hydrogen. Okay, this hydrogen. why it wants to give this electron to this hydrogen means what will happen means here oxygen it has a positive, okay, positive charge. Oxygen being an electronegative, if the positive is there, it will not be a stable one. So what will happen means this bond will break. This bond means one bond means it's a two electrons, no, this bond will break, and it again this oxygen will get two electrons, okay, two electrons. But as this hydrogen is donating its electrons, as the bond is broken, so it attains positive. Okay, so this carbon, no, so it is electron, electron due to that electronegativity difference polarity, it has a negative charge, so it passes, it gives two electrons to this carbon. So the arrow marks should be like this. Okay, that means this carbon is donating its electron to this hydrogen. So what will happen now, will happen now that uh, this carbon, okay, so this carbon hydrogen is attaches with this carbon, okay, so this carbon it has a positive charge on it, so this put positive, okay. So this one, this is water is separated, water is separated, okay, yeah. First step understood. So this is the protonation of um, alkene. Understood first step? Okay, so no one is responding. It's a nucleophilic attack. Second step, it is a nucleophilic attack. The first step, it is a protonation. That means H plus is separating. Okay, H plus is added to this carbon. So second one, it's a nucleophilic attack. Nucleophile means is what? It's a negative. So here, which one it attack? Which one? So it will attack this carbocation. So if write the carbocation here, hydrogen. So this carbocation is this. Okay. Then to take again it's water. So the two electrons are there, no? So these two electrons will attack this carbocation. You will get H, C, and then OH. Okay, so this water is added to this carbon. Okay, so this is nucleophilic attack. The second step it's a nucleophilic attack. Again, you put a plus here. Okay. Then third step deprotonation again. Deprotonation to form an alcohol. So now we are getting this one. No? C H, it's O H. Okay. Again, this electron, which gives electron to this hydrogen. Okay, so you will get, so this bond will break, and again oxygen will get its electron back. So what will happen means it's a CH, this OH. Okay, this OH is attaches with this, and then we will get H3O plus again. So whatever we used in the first step, we got it back. Okay, that is the part of, that is the role of catalyst. Okay, so it will not take part, but it fasten the reaction. So this is the mechanism. So the finally you will get an alcohol. The first step is it's a protonation. The second step is nucleophilic attack. Third step which is deprotonation. Okay, understood this mechanism? Hello. Understood? Mechanism understood? All are there now. Okay. Second one. So this is the first method. Um, from hydrocarbon from alkene, so that is by acid catalyst hydration. Okay, the second method is here, from alkene, it is the second method, hydroboration oxidation. Okay, so actually this method is applicable for secondary and tertiary okay, for secondary or tertiary alcohols to get. uh, this one second method, it is a hydroboration oxidation. Hydroboration oxidation. So this is for primary alcohol. Okay, so this is for primary alcohol. Okay, so here now what will happen means, so diborane. So diborane which reacts with alkenes to give trialkyl boranes. So what do you mean by diborane? So this is borane actually. This is borane. So diborane means two boranes are combined. So diborane with alkene. Okay, with alkenes to give trialkyl boranes as additional product. For example, so CH3, CH double bond CH2. So when it is treated with the diborane, BH2. Okay, so it's written right, and diborane. So what will happen? So here the hydrogen, no, so it attaches with this carbon, and then BH2 which is attaches with this carbon. So you will get CH3, CH, right? It's a CH2, BH2. So this is the first step involved here. Again, this one, if it is react with one more molecule of um, alkene, CH3, CH double bond, CH2, so we will get CH3, CH2, CH2. So here the two molecules are there, no? So CH3, CH2, CH2, twice it's a BH. Okay. So again, it will react with one more molecule, CH3, CH double bond CH2. So we will get a tertiary compound, CH3, CH, CH2, twice, twice B. Okay. Again, this one no. So on treated with again this one, this is okay, this is tertiary, the trialkyl borane is obtained. This one is oxidized to alcohol by treating it with hydrogen peroxide in the presence of aqueous sodium hydroxide. Okay, so treated with aqueous sodium hydroxide, so we will get primary alcohol CH3, CH2, CH2, OH plus BOH3. Okay, so this is propan 1 all. So here only it's an oxidation is taking place. Okay, so the hydroboration oxidations. First we have to get the trialkyl borane. So this is trialkyl borane. This is trialkyl borane. Trialkyl borane. So this trialkyl borane, no, it is treated with, it is converted or it is oxidized to alcohol by treating it with the hydrogen peroxide in the presence of aqueous NaOH. We will get propane 1 all. Okay, so propane 1 all. Here the addition of borane to a double bond which takes place. So here the sp2 carbon, no, so double bond means it's a sp2 carbon. So this is actually, it is, it takes place uh, okay, so which is opposite to Markovnikov's rule. Okay, so this is not go with the Morconic, so this is opposite to Morconic rule. So because this is a negative part and this one it's a positive, this one is attaches with the less hydrogenated carbon, so this is anti-Morconic. So it's go with anti-Morconic rule. So here the alcohol obtained is it's a very good yield. Okay, it gives good yield of alcohol. This method. Understood? So this is the second method. This one it's a second method. Understood? No? Hey, yes or no சொல்லுங்கப்பா please. Hmm. Okay. So this is the first method of preparation. First method is from alkene. Alkene we have seen two methods in under the heading of alkene by acid catalyst hydration one method and another method it's a hydroboration oxidation. Okay. Now we are going to see the second method. Second method from carbonyl compounds. What do you mean by carbonyl compounds? From carbonyl compounds. What do you mean by carbonyl compound? Carbonyl compound means this is a carbonyl group. Okay. So whichever compound has this carbonyl group, that is called a carbonyl uh, compound. Okay. So for example, if an aldehyde has a CO group, an acid has CO group, and then ketone has a CO group. So these are all carbonyl compounds. Okay. So under carbonyl groups, the first method is with reduction of aldehydes and ketones. By reduction of aldehydes and ketones. So aldehydes and ketones. Aldehydes and ketones are reduced to corresponding alcohols by the addition of hydrogen. Okay, in the presence of catalyst, that is a catalytic hydrogenation reaction. So we have seen already this lesson in the 11th standard and even 10th standard also we have seen. So by catalytic hydrogenation reaction, so it is reduced to alcohol. Aldehyde and ketones are reduced to alcohols, uh, corresponding alcohols. We will see that. Uh, First we will see aldehyde RCHO. Okay, RCHO. So with hydrogen and the presence of palladium as catalyst, palladium or platinum as a catalyst. So this CHO group, no, so which is converted to CH2OH group or CH2OH group. So that is primary alcohol. So aldehyde to aldehyde is reduced to primary alcohol. Here what you have to observe means the number of carbon it retains. Okay. So here the substrate which has one alkyl group with one carbon. Here also in the product, if you are seeing an alkyl group and one carbon. Okay, so this is uh, aldehyde which is reduced to alcohol. Okay, aldehyde which is reduced to alcohol. Then next one, ketone. If you see, if you take a ketone, ketone means what group? CO, no? CO group. This is ketone. General group. Here sodium borohydride. So that is NaBH4. So this is used as a reducing agent. Reducing agent like so this is the symbol for reduction. Lithium aluminum hydride can be used as a reducing agent and NaBH4 is also used as a reducing agent or hydrogen or with the palladium or platinum or nickel can be used as a reducing agent. Okay, here we are using sodium borohydride, uh, sodium borohydride or lithium aluminum hydride. Anything we can use, but this is little bit expensive. So we are using sodium borohydride. Okay, so this ketone, no, it reduces to secondary alcohol. Okay, aldehyde to aldehyde always reduced to primary alcohol. In the same way, ketone which is always reduced to secondary alcohol. Okay, CHOH or dash. Here also you have to check the number of carbon. So it retains the same number of carbon. Okay, by reduction of aldehydes and ketones. Aldehydes it's always reduced to primary alcohol, and then ketone it is always reduced to secondary alcohol. Okay, secondary alcohol. Then reduction of carboxylic acid is also gives um, alcohol. Okay, that is the reduction of carboxylic acids. Reduction of carboxylic acids. Here, not only carboxylic acids, esters also. On reduction, these reduction we will get alcohol, whether it may be a primary or a secondary. So here the carboxylic acid to acid which is reduced to primary alcohols by lithium aluminum hydride. Lithium aluminum hydride is a strong reducing agent. Okay, strong reducing agent. So it is directly without uh, getting aldehyde. So we are getting alcohol here. Okay, C or CH2OH. Again, you check the number of carbon. It retains the same number of carbon. So the first reducing agent we are using is lithium aluminum hydride. Then hydrolysis. Okay, it reduces to primary alcohol. If you are using lithium aluminum hydride, we will get excellent yield. Okay, so yield will be very good. So, but lithium, we know that this lithium aluminum hydride is a very expensive agent. So, we are using the special chemicals only. Okay, so commercially if you are commercially if you are preparing meals, so we need to take care of that profit also, no? So commercially acids are reduced to alcohols by converting them uh, to esters and then alcohol. Okay, because this is an expensive, excellent yield, but it's a very expensive commercial method. Commercial lab means we can prepare, but in the commercial method, so it is not a profitable one. So what they are doing means this acid, no, which is converted to ester first. So when this acid react with alcohol, okay. So in acid hydrolysis, you will get ester or COO or dash. So this is ester. This ester, no, again with the hydrogen, it is reduction. With reduction, hydrogen as a catalyst, it forms primary alcohol. Okay, so this is the method. This is a profitable method. So this one is a profitable. So this is an expensive method. Okay, so to for commercial, so profitable method only it is a commercial. That means it is a commercial method. Okay, so this is the second method by which alcohols can be prepared. Okay, so here one more method is there. So we will continue in the next class. Um, so I want